Today we're going to talk about rationalizing the denominator when you have complex numbers, specifically the imaginary part. If you remember, the square root of negative 1 is actually equal to I. So having that I in the denominator is like having a square root, which we need to kind of get rid of. And likewise, if you also remember that when you square I, and you square the other side of the equal sign, you're going to get that negative 1 is equal to I squared. So if we can simply get an I squared, we can eliminate our denominator. So we're going to try to get rid of this I by multiplying by another I. But to make it so that we do not change the problem, we're going to multiply by a fancy version of 1. So if we multiply by I over I, as you can see, you'll get 7I on the top, you'll get I squared on the bottom, and you can convert your I squared to a negative 1. And then in the end, your whole problem is negative 7I. So we're going to try it over here with A. We're going to eliminate this I. And so you don't need to multiply by 4I. You just need to multiply by an I over I, which is just 1. And then we will get 5I in the numerator, and we will get 4I squared in the denominator. And then the I squared right here will be eliminated, and we can replace it with a negative 1. Well, this brings us to 5I over negative 4. You are welcome to keep it like that. Most math books will take this negative and they will move it either here to say negative 5I over 4 or to say negative 5I over 4. They choose not to keep it in the denominator. So in our next example, we're going to, as you see, multiply by I over I, but I don't really like to have the I written there, so I'm just going to move it so you know why. And I'm just going to write it here for better distributing. And what we're going to do is now distribute it throughout the numerator. So I've got 4I minus 5I squared, and that's all over 2I squared. And we have accomplished what we wanted to. The I squared is going to cancel out to become a negative 1. It's going to be replaced. So now we have 4I minus 5 also times a negative 1 all over negative 2. Let's convert this little part in the top and turn it into a plus 5. Now, this is sort of done and sort of not. If they wanted in standard form, which is the form A plus BI, they want it in two separate pieces with the real portion first and the imaginary part second. So we're going to split this into two pieces. But I'm going to first split it into the real part, which is 5 over negative 2. I'll put the negative there. And then I'm going to split it into the imaginary part, which is the 4I over the negative 2. The only one that we can cancel will be the 4 and the negative 2. So we are going to make this into negative 2I. Don't lose this negative. We're going to say minus 5 halves minus 2I.